I'd love that.
Okay, so then what do? What's that mean? If it says in terms of x, what's that mean? If we're solving for z in terms of x, or writing z in terms of x, or something like that, well, the part I'm interested in is this in terms of x part. What's that mean?
X equals.
Not x equals. We're solving for z, so we're going to have z equals. But what's going to be over here? What's going to be equal to if it has to be written in terms of x?
Something.
Okay, we're going to get some stuff. We could get some numbers, right? And what else? X. Any y's?
No.
No, we don't want y's in our answer. We want our answer to be concocted of numbers and x's and stuff like that, but no y's. So what do we do? What do we do if we want to write z in terms of x? Now look at the problem up here. Up here I've got a y in my z expression, right? Z is written in terms of x and y, so how am I going to get rid of that y? This is a great trick in algebra to do a lot. What do you think? Now notice I've got this other equation here though, right? That might be useful. How could I use this blue equation to help me out? If I want to write the black equation in terms of x's exclusively, no y's. So I have to simultaneously do two things. I have to get rid of the y, and I have to replace it with x stuff. Right? How could I do that? Yes, what do you think? Yes.
On that equation, divided by 2.
Ah, okay.
So that you just got the y equals, and then fill it into over where the y is at.
Okay, let's take this equation up here, and let's solve it for y. So I get y equals, if I divide both sides by 2, don't I just get 5/2 x? Would you agree? Okay, now look what we did there. That's really good. That's a substitution equation, right? So every place, I've got the y by itself. So every place I have a y in my original equation, I can plug in that stuff for the y. It accomplishes two things. It gets rid of the y, and it replaces it with x stuff, right? Make sense? So then we end up with, we do that, z equals 2/3 times x, but now instead of the y, we've got a 5/2 x, right? Now that's good. That's our answer. We just need to simplify it. We need to clean it up a little bit. But I've got only numbers and x's in there, correct? So what would I do to simplify that? 2/3 times x times 5/2 times x. Suggestions?
Did you, cross things?
Well, I could, sure. Yeah, I could do some cross cancellation. Yeah. Do I want to? How do I want to organize what I'm multiplying there? If I multiply a string of 4 things together, does it matter the order in which I multiply them?
No.
Doesn't matter, does it? I can swap those factors and put them in any order I want to. So why don't we do this? Why don't we group the numbers together? So I've got 2/3 times 5/2 times x times x. Right? So then we get z equals, and what can I do with the numbers? Gabe suggested we cross cancel. Because I'm multiplying fractions, I can do that. I can cancel those 2's. And what do I get for an answer? 5/3. And then x times x is squared. There we go. We got it. Okay, it's simplified. Okay. All right. So that was one issue that seemed like people were having. Another thing that popped up was, let's see. I know what one of them was. The story problems. Yeah, the story problems. Now, I'm going to take an example. I had one, but the internet's gone, so I can't find it. I think there was one like this that came up quite a bit. And this is a good example. What if we have a 74-inch board is cut into 2 pieces. One piece is 11 inches longer than the other. And maybe we want to know what is the length of the longest port? Okay, something like that. So now before we jump into this thing, how could we approach this problem? Can we come up with a verbal model here? Where does the 74 inches come into this maybe? That's, I guess, total length, right? What's the total length equal to? 74. Okay, that's true, it's 74, but how is that related to the other pieces? Okay, they have to add to 74, don't they? Right? So we could say then that the short, I'm just going to abbreviate this, we'll call it the short length. There's one quantity, plus the long length equals the total length, right? And we know that this is 74, but we got to know what to call these things, right? So when we don't know something in algebra, what do we call it? A variable, an unknown, or a variable typically, right? If it's unknown, then we're going to assign a variable to it. Hopefully we can solve for that variable and find out what the value is. And that's where algebra comes in. So what could we call the short length then?
X.
Hey, let's just call it x. Okay? The short length is x, and we're going to try to solve for x and know what it is, right? Now, if the short length is x, here's something that people sometimes want to do. They want to call the longboard y, which is, you could do, but that causes a problem for us. Because if I've got two different variables in this equation, I can't isolate one of them and get a number back. Does that make sense? Okay, in fact, there's a general rule in algebra that you'll get very, very familiar with this year. You have to have, if I want to solve for some unknowns, I have to have at least as many different equations as the unknowns in order to solve for all those unknowns, to get number values. So if I have two unknowns up here, an x and a y, I would need somehow two equations to solve for those, right? We'd rather just have one. If we can find a way to just have one unknown, just leave it in terms of x, that would be great. Is there a way we could do that? Could we express this, the length of the longer board, using x's instead of some different variable?
Yes.
How's that gonna, what's it gonna be? Oh, okay, yeah. One piece is, one piece is, here, make it red. One piece is 11 inches longer. That must be the longboard, right? So how do we say 11 more than in math? Well, plus 11, right? So wouldn't this one just be, the long length be the short one plus 11 more? Right? Okay, and now that we've turned this into an algebraic equation, that's a really easy one, right? What do we do to solve this? We can just flip into algebra mode and forget about the problem. What's x plus 11?
2x plus 11.
And then we get 74. And then what are the two steps in order to solve for x?
Subtract 11.
Subtract 11 first and then
Divide by 2.
divide by 2. And what would we get? If we subtract 11, we're going to get 63 divided by 2, so that's what, 31.5 is, now what is that?
That's a short.
The short length, right? That's x. So to get the long length, what do we have to do?
Add 11.
Add 11 to that. Good. So we get, so what, 42.5? So there's our answer. How can we check to see if we got it right? Add them together. Yeah. Do they add up to 74? And they do, right? So we got it. Okay? Okay, another issue that I think came up pretty consistently. How about if we take a quick look? I'll just check and see if we got that right. The what? There, if you go, where do you get to these things? If you go to the Algebra 2 page, at the top it'll say lecture videos. If you click on that, it'll just take you to a page that'll have links to all of them. And they're, what I've tried to do with them, I try to put them, they're in, the newest ones are at the bottom. So it starts with the old ones and you just work down to the new ones. And I put a date on them and I usually try to put like a little explanation about what they're talking about. So this should be pretty easy to find what you're looking for. Nope, looks like we're still out of luck here. All right, well, that's all right. So kind of like a caveman, not having any technology up here to work with, but oh well. All right, so how about one like this? What if we want to solve, and get out your notebooks and just try this real quick. Everybody just try a couple of these. Let's do, let's try that. Okay, remember our trick here, if you want to call it a trick, is we're going to trade the argument of the absolute value function, meaning the bubble, we call it the bubble. It's all the stuff in there. In order for its absolute value to equal 7, either that stuff was already 7, or it was negative 7, and the absolute value made it positive, right? So we get these two normal equations then. Negative 2x plus 1 equals 7, or negative 2x plus 1 equals negative 7. So do you understand what I'm saying now? I'm saying trade the absolute value equation, because we got an equal sign in this case, for two regular, no absolute value going on equations. Okay, and then both of these are pretty easy to solve. What do we do to get to x by itself? Subtract 1. So divide by negative 2. So I get negative 3. If I do the same steps over here, negative 7 minus 1 is negative 8. Divide by negative 2. I get those two answers, negative 3 or positive 4, right? Okay. How could I check? Like if I were taking the test before I hit submit, I'd want to probably know if I'm getting it right. How could I check? Plug them back in. They should work in the original absolute value equation. They should make it true. Okay? Now, what if I said I wanted the lesser of the two solutions? Which one would that be? Negative 3. Greater would be positive 4. Good. Okay? Another one. Try this. How about absolute value? I'm going to give you a tricky one. Negative 2x plus 1 is greater than 7. These same numbers. So the algebra is going to look similar once we get to that stage. So what do we do first? Before we do any of that stuff though, remember before I can start doing any algebra, got to get rid of the absolute value stuff, right? So I'm going to trade the absolute value inequality for what? Well, for two regular inequalities in the form of a compound inequality. Either going to be an and or an or, right? Compound means 2 and 1, so it's a 2-for-1 deal. Now, I'll let you work on this. Before we jump into it, can somebody tell me which kind of inequality is it going to be? It could be an or. Isn't it? We know that if it's an absolute value of some stuff is greater than 7, that translates to an or inequality. So see what you can do with that. Take a second. Okay, so remember, here's our goal with this. We're gonna trade the absolute value inequality for two regular inequalities in the form of a compound. Now, everything in the bubble this time, remember what this, and think of this in terms, I think it helps. Think of this in terms of a number line, kind of what you should expect. Remember we said that if I have the absolute value of something is greater than 7, then that means that it was really extreme values, right? What numbers would work? What numbers could I put in the bubble there that would satisfy this inequality? Inside the blue bubble, if that's 7 and that's negative 7, really big answers would be okay. If I put in 1,000, that would work, wouldn't it? Isn't the absolute value of 1,000 greater than 7? Absolute value of 10 is greater than 7. right? But the absolute value of 5 is not greater than 7, is it? Right? So we know that we're gonna be, this is an OR inequality, so we're gonna be, so here's one of our ORs. It's gonna push out in that direction, right? Now what about if we look at the negatives? If I put the number negative 1,000 in the bubble, would that work? It would, because the absolute value is making it positive, right? If I put a negative 10 in the bubble, that works, because the absolute value of negative 10 is 10, which is bigger than 7, right? So big negative values work, but if I put in negative 5, that's not going to work, is it? Right? So then I've got to go this way also. So there's my oars on a boat, right? How do I say that now in terms of two different inequalities? Well, this one up here is just going to look like everything in the bubble has to be greater than 7, right? Greater than means to the right of on a number line, correct? So we get negative 2x plus 1 is greater than 7. And what about down here? How do we say this stuff? This is all the numbers that would go in the bubble. So the value of the bubble would have to be less than negative 7. Less than meaning left of on the number line, right? So there are the inequalities that are going to work. Now we've just got to solve those for x, because we don't want to know what numbers are in the bubble. We want to know what values of x will work here, right? So then the last step would just be to isolate x in both cases. And the algebra steps are going to look pretty familiar. What do we do to get the x by itself in both cases? Subtract 1. So let's do this one first. So negative 2x is less than negative 8. And now what? Okay, but if I divide by negative 2, what do I have to do? Good. Okay, so that sign's going to get flipped around. So there's one of my answers. X is greater than 4. 4, if we work on this side, if I subtract 1, I get 6, right? Divide by negative 2, I get, what, negative 3, but I got to flip the sign around. So it looks like that. Now, what I saw going on a lot was people said this, we're fine with that one, but when they wrote the second inequality, they wanted to make that a greater than sign instead of a less than sign. Okay? What you want to remember is, oars on a boat. Either it's going to be bigger than the limit of 7, or it's going to be way out to the left, less than the negative value. So it's left of the negative value. Okay? All right. Let's try another one. I want to make sure you see if we get one right here. How about this? What if we have absolute value of 3x plus 5 is greater than or equal to 15? Okay, try that. Is it going to be an and or an or? Or. Good. Okay, minor reminder. Let's keep going here. How would I say, how would I write? X is greater than negative 2 and less than 10. Do I have to actually write the word and this time? No, I don't, do I? I just put the x in the middle. And if I want to, what would I say? X is greater than negative 2 and less than 10. I would just write like that, wouldn't it? Right? Because an and means I'm going to have an interval that's got endpoints on the top and the bottom. It's going to be trapped between a lower number and an upper number, right? Okay, so I'll do the same kind of thing with the problem now. So what do I do with the bubble this time? If I know that its absolute value is less than 9, so it's pinched between two values, what am I doing with the bubble? What numbers work? Well, numbers that are between negative 9 and positive 9, including the endpoints this time, right, would work, wouldn't they? Because their absolute values are going to be less than 9. But really big negative numbers or positive numbers won't work. Like positive 1,000 won't work. Negative 1,000 won't work because those absolute values become positive 1,000, which is way bigger than 9, right? So So what's that tell you then? What do I do here? Okay, it has to be less than 9, greater than negative 9, right? So everything in the bubble has to be pinched between those values. Well, what's in the bubble? 4x minus 3. So we want to know the x values that are going to make that work. So we got to solve for x. What are our steps?
3.
Add 3. What am I going to get here? Negative 6, 4x, and what about here?
12.
Okay. Now what? Divide by 4. And so I get what? Negative 3 halves, right? Negative 1.5 x and 3. Okay. And that makes sense, doesn't it? X, that would work. X, we could think of some values that are bigger than negative 3 but less than 3, right? Okay. Okay, now you try one of those. That was our review. Now you try one of those. An and. Okay, so I'm going to trade this absolute value inequality for a compound inequality. It's or and. And, good. Remember, and's the one you don't write. You don't ever write and. It's just, you have to write or, but you never have to write and. So how do I set this up then? Okay, so the bubble, 2x plus 1, is, okay, is greater than and less than the extreme values, right? So greater than negative 5 and less than 5. Good. And once you're there, you're set. At that point, it's a piece of cake. Just subtract 1, divide by 2, and we're there. Now, what about this one, though? There's one other one, and I won't make you do the whole thing, but I want you to kind of get me out of my predicament here in this one. What if I'm doing something like this? The absolute value of negative 2x plus 1 is less than 10. Okay. Now what do I do? Here, I'll tell you what, let's even make it, we'll make it work out real nice. We'll make it a 9. So how do I set that up?
Negative 2x plus 1.
So whatever's in the bubble, good, is less than 9, okay, and greater than negative 9. Okay, so what are the two steps that go through here? Subtract 1, so that makes that, what, a negative 10, negative 2x, and an 8. Now what? Divide by negative 2, okay. And so what's that telling me I have to do? Switch all the signs. Good, so I'm going to get a positive 5, an x, and a negative 4. But I have to flip all the signs around. Now that's doesn't fit in with Moodle well, for a reason. It's not meant to. Is that a good way to write that answer? No. We got to take the whole thing and flip it around, right? Because we want to have the lower number. Negative 4 is less than 5, so the lower limit should be on the left. The upper limit should be on the right. So we'll just take the whole darn thing, flip it around, so the x stays in the middle. But after we flip it around, whoops, sorry, that's not it. The 5 ends up here, and the negative 4 ends there, and the signs get flipped. So that's our answer. Okay? We good? Okay? Good. Good. Yeah, I think so.